let's chit
Oh, I
chat.
need to say it.
Let's chit chat about the lab from yesterday. So here's what I'm looking for, is that you should have a tension, and then down here you have that weird area GH, okay? And so your areas probably, hopefully, are like something times 10 to the negative fourth meters squared, okay? So that's typically where those areas are gonna be. So what you should see on here, and these are actually gonna be negative values because of the fact that as you increase that height, you decrease the tension. So you should see, hopefully, like, you're gonna have two lines. One's gonna be, like, for example, this is your water graph, let's say. So you should have, hopefully, relatively, two kind of parallel lines on here. So, because, and this is the whole point of this, is that you're finding the slope of these lines. And the slope of the lines don't represent the density of the object, they represent the density of the fluid. So because they're parallel lines, it doesn't really make any difference where they are because you're talking about the slope, okay? So make sure I know which line is which is your aluminum line and which is your iron line. Now, hopefully what happens is that then you get another one with the alcohol line, and you're gonna have that same AGH, okay? So you can actually use the same scale for both of them because it's the same area GH, okay? So what you should see again is that you should see two lines, and hopefully these lines are a little bit less steep than the water lines because your ethyl alcohol is less steep than the water is, okay? So that's kind of the whole thing. So make sure, because you only have like a couple of points on here, okay? So make sure you show me, hey, here's how I found that slope. On the questions that you have to answer on that experimental error, technically your slopes are negative, but these we're talking about densities, so just make them positive because you're just talking about the difference of the densities. And assume that you're using like water, so you can just use a density of 1,000. And then you've got that density of the alcohol 792 as that. So any questions on the lab?
What's an acceptable like experimental error on this one? Because mine's like really big,
Like how big?
like 200%.
Well, how?
How do you
Whoa.
get 200% error?
Because my slope is negative 1095.
What?
You're missing a decimal somewhere.
Yeah.
1,095 or 1.095?
No, 1095.
Oh, you messed up.
For your water?
Yeah, because
Well, that isn't a big deal. You're taking 1,095 minus 1,000 and divided by 1,000.
you said it was theoretical minus experimental.
Over
Divided,
theoretical.
yeah.
And then it's an absolute value, so it
And
doesn't make any
theoretical-
difference which one you subtract, because it's an
Theoretical's
absolute
1,000.
value. So
Okay.
yeah, technically it's 1,000 minus 1,095 divided by 1,000.
So what is that?
So it's just 95 over 1,000 times 100, which is gonna be like 9.5%.
Okay. Okay. I had added them.
0.95.
I was about to say.
You added them? Yeah, 9.5%. That's a good. That's like
That's
Yeah.
jacked up, retort.
9.5%.
That's
Yeah.
That's a lot better.
Yeah, there's a big difference
Thank
between
you.
200% error and 9.5% error. Yeah,
Well,
okay,
glad I cleared that up.
so am I. Okay, anything else?
Oh,
Louis?
can I have it?
He wasn't here
Who's
yesterday.
God, you're so demanding.
The other one's
So
2.9.
demanding,
May I
bro.
please have it?
Hey, you. Yeah, you did good.
Here.
Yeah, I just wanted a gummy bear.
Thank you. What's
Get the
up?
data from,
Got the data from Pop.
yeah.
If he's even got it done.
Okay,
That's the whole thing.
now
bro.
anything else?
I'm fine.
Going once, going twice?
So,
So.
Cool.
Shut down. Okay, so today we have to go through like some random equations that don't necessarily look like they're related, but they are. So, over here on yonder purple sheet, on this fluid mechanics and thermal physics, this is what we're gonna do, is we're gonna finish up the last of these equations today. They're related, but yet they're kind of different, but they're kind of cool because they impact like how you fly and why airplanes go up in the air and even NASCAR and a whole bunch of kind of random things.
NASCAR?
So here's the story. So let's just start with
Thermal.
this idea that I've got this fluid here and
I'm sweating, bro. It's so hot in here.
so it's kind of a demo day kind of thing. So I got some random,
Balls are very different size.
okay, so let's start with this idea.
I'm not just gonna ball that big.
When you talk about pressure,
Steel ball.
okay? At the end of the day, what do you divide by to get pressure?
It's M over, no, it's not M, it's force over area, right?
Yeah, force per unit of area, right? And in physics, that's gonna be newtons per
Meter
square
squared.
meter, right? Okay, force per unit of area. So I've got two different spheres, okay? This one and this one. So, Vitor, catch. Okay, you ready?
Yeah,
So I got that one, now set that one down, and I'm gonna throw this one to you.
Okay.
Ready? Okay, now I want you to hold them up like this. Which one weighs more?
I think this one.
By lot, by little?
By a little, if it does weigh more, if not, it's the same.
Okay?
They have to be equal.
It's gonna be the same.
They're gonna be the
They
same.
probably are the same,
They are the exact same.
but this just feels
Okay.
heavier
Why?
because there's more, it's more dense.
So why?
It's more weight.
Explain
on
it in terms of,
Pressure, so
This.
there's more force acting on
No.
a smaller area of my hand.
no, not
Same
more
force.
force.
The same force acting on a smaller area, so it
Okay.
feels like more pressure. So it is more pressure.
There is more pressure, because both of those weigh about 150 grams, okay? The mass is about the same. So if I take 0.15 times 9.8, I get about 1.5 newtons, okay? So
That's the
each
ball.
It's
one,
light.
gotcha. So each one roughly weighs 1.5 newtons, okay? So if you hold them up, each one has, but that smaller one, right? That's concentrated in a much smaller area. So you're tempted to go, oh, that one feels heavier because you're associating pressure with
Wait.
force or weight, okay? Now, throw them back.
You got this?
Yeah,
Both of them at the same time?
yeah, not at the same time.
Okay.
Okay,
There we go.
so if I take this one and I put it in water, sinks like a rock,
Splat.
okay?
Doesn't displace.
I put this one in water and it floats. Okay? Exact same weight, right?
Density's less than.
So why does one float and the other one sinks?
Density's
One
less
is-
than water's density?
Greater volume,
No.
greater buoyancy force.
Okay,
I guess so, yeah.
let's talk about this.
Greater.
The pressure of the ball is spread out between the water, so it's
Hold on. Hold that thought. Okay.
That's right.
no.
You're right. No, you're right.
So when I put both of them in the water, what do they have in common?
Mass.
Mass.
They have the exact same gravitational pull of 1.5 newtons, because they both weigh the same, right? 150 grams, 0.15 kilograms, round G up to 10, 10 times 0.15, you get 1.5, okay? So they both have the exact same gravitational pull. Do they both have the exact same buoyant force?
No.
No, because again, how do you calculate buoyant force?
Density of water times volume displaced times
It's the
G.
weight of the fluid that's displaced, which is exactly what Pop said. So the buoyant force is gonna be rho v g. What's the same for both of those?
G
F.
G is gonna be the same,
and rho.
And rho, is that the density of the object or the density of the
Liquid.
fluid?
Water, fluid.
Density of the fluid, right? So that's gonna be the same at 1,000 kilograms per cubic meter. Okay, cool with that? So, why does then this one float and the other one sink?
Larger
More water
volume, so there's a
Larger
greater,
volume.
there's a greater point.
Ah, so as that volume increases, what's gonna happen to that buoyant force?
It also
Go up.
It's gonna go up. Now, if you were to look at this, okay, so this is down, this sinks down to about this point right here, okay, that's about where the water line is. So as a ballpark estimate, how much of that volume is below the surface?
Some of
10%?
my questions,
10%,
theoretical.
okay? So if that's about 10% below the water line, that means the overall density of that sphere is about 10% of the density of water, which would be about 100 kilograms per cubic meter, okay? So if you know how much is below the water line, you can know, oh, that's an approximation of that density of that object compared to water. If we were in ethyl alcohol, it would be a completely different thing. Now, if I push this down and let go, what's gonna happen?
It's gonna accelerate
It's gonna accelerate upward. Why?
because it has a force.
Buoyancy is
buoyancy.
greater
Yeah,
than force
because as I
gravity.
push it down,
More volume.
what's happening to the buoyant force?
Going up.
Increasing because there's more.
It's increasing because I'm displacing more and more
Volume.
water. Buoyant force becomes greater than the gravitational force. It goes up, right? Got that idea? Okay. Now, I'm going to take this fluid here, which is just water with some food coloring in it, so you can see it a little bit easier. It's just yellow food coloring. And what I have here is that I've got, these are all connected by a common manifold down at the bottom, okay? So I've got one that's just like this big straight column. I've got one that's kind of got a little zigzag on it. I got one that's got like a little bubble here, a second bubble. And then this one's just a small thin line. And so what I'm going to do is I'm going to begin to pour that fluid into this bigger one, okay? And then it's going to flow across, and so it will go up. So here's my question. I'm going to pour this fluid up to about right here on the big column, okay? So I'm going to fill this thing up to about right here. So the question being is that what's going to happen to the fluid in here? So I'm going to fill this one up to here. So option A is that it's just all going to be the same all the way across. That's option A. Connor, you've already just shaken your head no.
I don't think so.
So which one do you think then, if they're not the same, are they going to be higher or lower than this one?
I'd say lower
Why?
because it looks like they're gonna have to take different paths, and then the small skinny one, it's gonna get less water than the rest since it's all the way on the end.
Okay, so you don't think this, so you think, of these three, you think this one's going to be the lowest?
Yeah.
Because it's at the end and it won't get as much pressure to push that water up. Because it says this is, so then by your rationale, then would you think this one, other than this one, you would think that would be the highest if you follow that thought process?
By that thought process, yes.
So this would be the highest,
Yeah.
and then this one, and then this one, and then that
I
one.
think the bubble one will be the lowest.
You think the bubble one would be the lowest?
Yeah.
Why?
Because, I don't know, there's spaces in it, I don't know how to
So
explain.
you think maybe that's going to consume some of that fluid and
Yeah,
fill
and then
this,
it's
and so that
gonna-
it won't have as much fluid left over to go up. Okay? Louis?
They're all going to be the same, but I can't put it into words why. I think it's something to do with it has to be within equilibrium on the original tube. And since that has to come down a certain way, then they have to match it.
'Cause-
And it doesn't really matter on how much space it's going to be because
Is it
it would
'cause-
still be
Yeah.
unequal if they were not level.
is it 'cause pressure is constant everywhere?
I
Is that why it would be?
can't really explain it, but I just kind of know
It's
it.
just a gut feeling.
Mm-hmm.
And
I
don't,
just-
don't discount gut feelings.
I think the smaller one. No,
Define
I'm
with
just
this
not gonna
one?
say anything.
Say it, I said my dumb
Go ahead,
thought.
Pop.
I said my dumb thought.
I thought the smaller one
This one?
might like fill up.
It would be
first.
higher.
I think it might fill up first. And
You
it
think
might
this
be
will-
higher.
Well, fill up first.
I
and
think it'll
filling
fill
up
up.
to the
No,
same
no,
height is different.
let's leave that out of it. This isn't a race. I'm just saying, once I stop pouring and this thing equalize, when it reaches some sort of equilibrium, okay?
It stops moving.
That's the end of our question. Are they going to be level once I stop pouring? Or is there gonna be a difference? So Louis is on
I think
the level train.
I'm on different.
just to put
train.
another opinion.
You're on a different train.
Just to put another opinion in there. I'm gonna
Pop's
say
on
the,
no train.
the far one is gonna be the highest.
Then you think this
Yeah.
one's gonna be the
That one
highest?
will be the
I'm
Pop-
walking on those trains.
Because you're saying it's gonna come down here, it's gonna hit this first,
Yeah,
and that's
And
gonna
but
fill
then-
up first, and that's gonna stay higher than the other
I
ones.
think.
I think it's just less volume that it has to go up. So it's
It could
Yeah.
be,
That's
that would
what I'm
be
thinking
kind of
too.
what I was.
well, because the
Yeah.
volume
what I'm
occupied might be
thinking.
the same, but that might not be the same height. Then
Okay,
that might be it. But I don't know.
Could be.
so we've heard from the middle, but we haven't heard from,
The edge or the
from,
back.
from the.
Give it a try.
Never hear from
Keaton,
the
come on,
edge.
Keaton.
Hop on a
Keaton.
train.
I on the pop train with the one on the far right being the highest.
The pop train.
So the
Pop
pop train
train.
has,
Pop train's rolling.
Devin,
Well,
I think they're gonna all fill up equally.
why?
Yeah, Louis
Because
train.
the pressure acting upon them is going to be the same. There's
You're not
nothing
on my
like
train.
pushing, or I guess like,
We should all take a
But
bet. and
pressure
all
is
proceeds
per
go
I'm
to
area.
kinda on the
solar
pop
farms.
train, I just know they're gonna fill up all of the
He
same,
knows.
like,
You know.
He knows.
He knows.
It'll be.
okay.
He's like
Like,
a
how much
money are you
I'm not gonna
physics.
say I know.
I think
How much-
each-
When I fill up, like, a gallon jug full of water, and there's that little, like,
Handle?
the handle, and the water fills up at the same rate as the handle.
Damn.
Oh, he's
Why
right.
I
Okay,
think that's gonna
all right. Jackson,
I'm cool.
He's gonna have to die to grab more than.
what? You gotta take a stand on this one. Pop train, counter train,
Or Louis
level
train.
train.
Level train since it doesn't have a Louis. It's not named Louis.
Pop train.
The Louis level train,
Yeah,
the
that is.
LLT.
I could see why it would be
I can see
either of the two
I can
because
see either.
level because.
But not three.
But the thing
I
is
just
that
can't see Connors.
pressure is over
Where's
area
the roll?
squared. It's like it wouldn't have to be the same height. It would just have to be the same volume, and then
Yeah.
so the one on the right
That's what I'm saying.
would go higher to equal the same volume.
Bubbles the lowest.
So I think I agree with you.
Yeah.
So
Which one?
Vitor's on the pop train.
I think
Okay,
so.
Jackson,
I'm gonna be mad if your train doesn't work.
That makes a lot of sense.
so you're on the pop train too.
Can I add one more opinion?
Yeah?
It's
Pop
gonna
train's
go.
rolling.
It's gonna go from order of lowest to. It's gonna go
Is that a phone?
2, 2, 3, 4, 1.
So which one's two?
First one, very first one.
That's two.
Far left.
This one?
No, far left. Yeah.
How is
This
that
is
two?
two?
Is
Yeah.
that one?
That's the second
Why is
highest.
The
This one.
second highest.
This will be the second.
Because it has to,
Which
like-
one will be the highest?
The far, your far
You
left.
You're
think
on the
this one's
pop
gonna be the
train.
highest,
Yep.
and then,
One.
And then the
or-
second,
okay?
and then the third is gonna be the zigzag. Then the fourth is gonna be that. Yeah.
It's gonna be
Okay.
You're on
lowest.
the pop train.
So why do you
Admit it.
think this one, Louis, is gonna be the lowest?
Because it looks like it has more volume overall that it has to fill compared to.
Because it has to fill up that bubble.
You're wrong. You're wrong. Louis. You're wrong.
Pop?
Look at.
I feel like
the
those two are
diameter?
the same.
Vitor.
I feel like those two are the same volume.
Which two?
Like the
second
first one and the
zag and the
third
bubble.
one.
This one?
No, the first one on the left.
This
No.
one?
Yeah, that one.
Okay.
And maybe the.
And the
No,
bubble.
use your eyes. Look at.
How's that
Those
work?
spheres are about the same diameter as the diameter of that whole tube.
Yeah.
If there's two spheres,
How
and
is
it
it
goes
the same?
skinnier, that one definitely has more volume.
Okay, so that one's gonna be the lowest. It's gonna go 4. The one on the right is gonna be 1.
Yeah.
This is
One.
gonna be the highest.
1, 2, 3, 4.
It's gonna go in order.
I think the 2 in the middle might be the same, but I know it's 1 and 4. And I don't know about that.
So
Yeah.
you're saying this is gonna be
The
the
two in the middle,
highest,
Yeah.
yeah, the two
this
in
is
the middle
gonna be the
might
lowest,
Yeah,
and then we don't know about these two.
possibly.
yeah, possibly.
I
You
think
can
that,
make the argument that this might be the lower one because it has to take water and
Yeah.
fill up that reserve.
Oh, and then that one's like
yeah.
pretty. That's like the same volume as that one. No, I mean it's a little bit more.
So these two are the exact same
No,
size,
no.
diameters.
Same
You asked
diameter,
Vanessa
but it's
what
longer.
it was,
But it's
More
longer.
volume.
I think it'll.
What train are you
I still
on,
think it'll be
Vanessa?
equal, but I'm just.
Louis still on the level train. He's solid on
I'm
the
still
level
level.
train. Okay, are we ready?
Yeah.
Vanessa?
This
We're
is
gonna-
like-
we're gonna-
We haven't heard
This
from
is the
you.
biggest
Hey, would
decision.
anybody like to bet $10 to the solar fund?
What train
Let's
are
make
you
a pot.
on?
Let's make a pot.
Huh?
Everyone
What
put
train are you
$5 in.
on?
I don't get to vote
He's a
because
conductor.
because I know the answer.
He's a conductor.
Yeah, I'm the
Yeah.
engineer of this train. So you got to take a stand
I'll go with the level train.
on the Louis
Yeah,
train.
there it is.
Hey,
Who's taking his
so we
son?
got two
Louis
people
level
on the
train.
Louis
Riding
train.
with you.
Devin, where were you at?
Just live for you.
You were on the level train. So we got three on the level train, and then we have very Aspen
Level train.
level train.
We're on a different.
Wow.
Level train.
They
Okay.
ride in that train.
All I know is no one's
I'm
on
on
the
my
Connor
train.
No one's on the Connor.
Nobody
Alright.
hopped on the Connor.
Connor, you know what I
So
hope?
here
I
we
hope
go.
you're right, Connor.
Connor
Right?
had the opposite train. Yeah.
Connor's on the
And
opposite.
Connor's on.
He's on
Connor's on the Connor train.
On ops train.
Okay, so here we go.
Oh yeah.
Okay,
Uh-oh.
so we're starting to fill.
Oh, we like that.
Uh-oh. Well,
Damn it.
Yeah, we like that. Yeah, we like that.
Oh no.
They're
That's
all
exciting.
the same.
Well, that's a shame.
well, yeah. If you're gonna go all the way up,
What?
There we go.
I know.
well, if you went all the way up,
I had a good feeling.
Keep
about
going. Let him overfill.
Is it
What
because
did I say from the beginning?
is it because when
I
they
said
have
I'm
to
just
fill the
putting a different
reservoir,
opinion.
there's more pressure to equalize than there is on the outside ones?
Louis, is this your phone again?
You're right. You're getting called.
Yeah, just turn it off. It's probably a spam call. Thank you though.
it's probably your work.
Okay, so let's talk about
Who's
this
probably getting
equation
fired
right
right
here. Okay? So here's the story.
Not these equations again.
Wait, what are
This is
these
the-
ones?
You've never seen
I've
these
never even
equations
seen
before.
this one.
I've seen it on the worksheet.
No, that's the same thing as V equals VO
No,
plus
it's not.
No, it's not, Louis.
2AD.
Okay,
It's pressure.
so let's talk about, and this is gonna form the basis of some
It
things
says
we're gonna do
something.
today.
You sure that's
So
on the
P
list?
naught, and this is this, let's look at the units, right?
Yeah.
So pressure naught is your standard, whatever your standard atmospheric pressure is. So since it's open, do all of these have the exact same atmospheric pressure?
yes.
Yes, okay? So P naught is the same, and that's gonna be newtons per square meter. If we're under 1 atmosphere, which is about what we're at, that's 101,300 newtons per square meter. Cool with that? Got it. Okay. Now, this is rho GH. So rho is gonna be the density of the fluid. Okay? So that density, oddly enough, then has to be in what units?
kg per meter cubed.
Okay? Kilograms per meters cubed. If we're water, that's 1,000, right? Then we have G, which is meters per,
Second squared.
and then we have a height, which is gonna be in meters. So if we look at this and go, okay, well, we got newtons per square meter, right?
Yeah.
So we can cancel out one of these, okay?
Cancel out another.
So now we're at, well, hold on, no.
Oh, sorry.
Okay, so that just leaves me meters squared down below,
Yeah.
right? Then I've got kilograms meters per second squared left over. Kilograms meters per second squared is the same as Newton, so oddly enough, I get newtons per,
Meters squared.
now that's the only way that I can add them, okay?
Oh, that's weird.
Yeah. That's what I'm, on the worksheet, that's what I did. It's like,
Yeah.
why do you not cancel half of them?
Because that way I can have pressure and pressure, okay? Now, here's the anomaly.
Silly. It's quite silly.
If you look at this example, okay? So let's say that everything is under the same atmospheric pressure, right? Everything's open. It's the same density of the water, that's the same, right? G is the same for everything, and H is the depth. So if I drew a line right across here, okay? That went here, split the middle of this lower bulb, and that column right there. Would they all have the same pressure?
Yes.
Yes. Is the area of the tube a factor?
No.
No.
Can't plug it in if you tried. So the only thing that determines the pressure at a point is the density of the fluid,
The height.
the height, and your gravitational acceleration. That's it. Nothing else matters.
Is that height gonna be negative? Or
No, it's technically, it's more, like with water, it's gonna be your depth.
Yeah.
So, it's just gonna be like an absolute value, because you're talking
Okay.
about pressure.
I got you.
So this is why, if you've ever gone swimming,
Swimming.
and you swam to like the bottom of the pool, what do you feel?
Ears pop.
Your ears pop, because of the fact that P equals P naught, P naught plus rho G
I feel like you're drowning.
H. So as you swim deeper and deeper and
Water filling
deeper,
your lungs.
your P naught is staying the same. So as that height or depth becomes greater, you're squeezed more and more. So if you ever join the Navy and you're in a submarine, you better have a pretty solid understanding of that equation. So when do submarines implode?
When they go too
At the
deep.
surface or when they go deep?
When they
Too
go too
deep.
deep.
When they
Too
go
much
deep,
pressure.
because there's so
When they
much
get hit by
pressure.
rockets.
So like a former student of mine, she was in the Navy, and she did
She
some
imploded.
pretty like top secret stuff. She was at Burr Camp. I can't even tell you some of the things I've done. I said I respect that. But she was in a sub off the coast of Hawaii, and they did this as a demonstration. So when the sub was at surface, they took a string and they ran it from one side of the hole to the other, okay, and the string was tight. They went down to like depth, like the maximum depth that submarine was rated at, and that string was bowed like this because there was so much pressure that was actually squeezing that hole together to the point that that string became slack because there was so much pressure on the outside of it. So if you ever go like, that's the problem. It's like, you go to like the Marianas Trench, which is the deepest part of the ocean. You get down into there, and that's why, the fish that are there are so well adapted to that extremely high pressure because they have all of that column of air or column of water that's above them pushing down. Louis.
So if
What would
the
happen if those fish went to
if the submarine didn't stabilize on the way up, would it like blow the hatch off if it came all the way up?
Yeah.
Well, yeah, that's why generally you do that slowly to let everything equalize. And if you ever get into scuba diving, you better be very aware of this equation,
You
okay?
get the bends.
Yeah, because what happens is if you depressurize too quickly,
You die.
what will happen basically is the dissolved oxygen and nitrogen in your blood boils, and that's what causes the bends because you don't allow your body to equalize over a period of time. That's the problem with with submariners when they have an escape hatch. Well, if you get out of a submarine and you're down at below the surface level and you go up too quickly, then it's just what Pop said. You're going to get the bends, and
What's that?
that's going to be that. Basically, the oxygen and the nitrogen in your
It
blood boil, and you have like pockets of that air inside of you, and it causes your muscles and everything to basically because you're stopping the blood
Yeah.
flow because you
that's
have pockets of
cool.
air inside your blood.
And then you die.
That's a bad
cool.
thing. Yeah.
Not cool.
Okay.
Experiment done.
Now,
Let's see if someone explodes.
so where's my YouTube?
It's so random, Colin.
Literally.
YouTube.
So here's my YouTube.
insulted me.
Okay.
I was kidding. Who said
So-
Kidding when that.
Got my YouTube.
Wait, so if you had something that wide, and then one like that super skinny, it would still go the same level?
Yep.
That's super weird. I don't like that.
Sorry.
Oh, what?
How dare
Where'd
you
you
not
get
like
all this stuff from?
YouTube.
Make some.
It's a YouTube. Literally. This is the original YouTube. Okay? So, all right, so I got this action going, right?
That's funny.
So, if I come down to this depth across here, would they both have the same pressure?
Yeah.
Why?
Because there's equal
Equal
pressure
height.
acting on the top.
Right? So I've got a certain amount of pressure pushing down. It's the same fluid. Everything's the same, right? Go with this idea. Now, we'll pour this
Like a
out.
blow.
Can you hold one side?
Oh, that's gotta be
Somebody
weird.
both
Hold
blow
that.
into sides.
How you
And then-
been
Oh,
pulling
with
it
the
out?
tube?
Yeah.
Oh, with the
Oh,
yeah,
yeah.
I used to
What?
play that a
That's so
time.
fun.
What?
Also good.
With the
Pool noodle.
yeah, the foam pool noodles where you used to blow and
Oh, yeah?
yeah.
You blow
And
them?
the other person blow. And like
Yes.
whoever
The wars-
stops, you
yes,
get.
the wars, it goes straight in
When you
your-
start laughing,
Oh. That was the worst.
those are the best. My mom thought it was the
Okay.
most disgusting
Oil.
thing ever.
So now I got some
It
cooking
really
oil.
was.
So what do you
It's
know about the
nasty, but it's
density of
fine.
oil relative to the density of
More
water?
dense.
Heavier. I've done
Which one's more dense?
Oil.
Oil.
Oil is more
Oh,
dense.
Yes.
No.
No.
What?
Yes, it is.
Yes, it is.
Isn't it thicker?
Oil is more dense.
This isn't thickness, this is density.
Oil is.
Oil is.
So hold on, so if oil is more dense,
No,
when I
what's
pour
less,
this
it
in here,
floats.
when I pour this in here, what should happen if oil is more
Oil is
dense?
less
It sinks.
It should sink.
It's less.
Oil is
so it
less than
floats. Go to the other
You
side.
sold us. Pop.
Oil's less dense.
That's
Your
wild.
mind.
No, it's
Did you
That's
guys not
crazy.
know?
That's
Oil.
actually crazy.
Your plan, right?
Invisible.
Oh, are they not at the same level?
So I got oil over here,
Oh, because. I'm sorry. Do you want
keep
me to?
going.
Okay, so because the oil pushing down, the pressure of the oil pushing down equalizes the amount of water that goes up the tube because it's only pressing from this side. So it's kind of like equalizing. Right
Well,
there.
it's the force buoyant. It's the buoyant force.
No, leave buoyancy
No,
out.
no.
Do not throw buoyancy into this.
No?
It's because it's got a different density, so it has greater pressure.
Because there's
On the
more,
top.
there's less oil, so it equals the same amount of pressure as all that water.
What do you mean there's
It just
less
pushes
oil?
down, and the
Here's the
displacement is
level
the
of
same.
oil, there's
Displacement.
the level of water.
I know, but the level of water, like if you poured
He's
out
saying
the
it's not
if you
half
poured
and
out the water, right, and then poured out the oil, it'll be less. So
Hold
the
on,
amount of
hold on,
pressure
hold
that
on.
the oil
Hold on. Stop.
Oh man.
is applying.
Stop.
Stop it.
Okay. Here's our YouTube, right?
Oh, now I get it.
Shut up, Vito.
I'm
So
serious,
here's
bro. I didn't understand
this
why I was
mark.
calling it
Funny,
YouTube.
Okay? It's got YouTube.
You just got that?
Yes.
Oh,
I didn't
my
understand.
What do you think I laughed?
We're going
Something
over
else,
in class,
yeah.
not the YouTube.
Yeah, I was like, oh, he understands it now.
So
Oh, it's YouTube.
here's the oil, right? And there's the water. So here's this interface, and they don't mix, and this has to do with chemistry because likes dissolve likes. So oil is a non-polar molecule, water is very polar. This is why they don't mix. Okay, so this is why I have this nice interface between the two of them. Okay? So the oil level is a little bit higher than the water level is. Okay, so this is really important. So the height of my oil is greater than the height of my water. Cool with this?
Yeah.
Okay. Now, if I were to draw a line across that interface between the oil and the water, and over here to this, which one has more pressure at that depth? The oil-water interface, the water line, or is it the exact
The
same?
oil, because
the
it's a lot
same.
bigger height.
Higher height.
It's the same.
It's the same.
It's the oil.
For just the stuff under there?
All I'm talking about is if we had a tiny pressure gauge, and we could measure the pressure at this depth, and we could measure the pressure at that depth, which one would show a greater pressure?
They're the same.
The water line or the oil?
Water's more dense.
Same. They're the same.
P equals P naught plus
There's a height in there.
plus density GH. Yeah, the height is the same.
No,
And
it's
the
not.
total-
The oil's higher.
No, but from the line. From the
Oil is
line.
higher.
Oh.
I was talking about
Oh,
what's
you're
above it.
okay, but that height is what's above it. The height is the height above it.
Yes.
Okay, so then they're the same.
Yep. Just
What?
nice try, Vitor.
Okay.
Well, I thought I didn't know
Wait,
the
wait,
height.
Five circles.
Hold on.
So confused.
Relax.
Okay, look.
There's a diagram on the.
P equals P naught
Plus.
plus rho GH. True?
Mhm.
Is P naught the same for both of them?
Yes.
Yes.
Yes. Why?
Because it's
One is
14.7
atmospheric
psi.
That's your standard atmospheric pressure, right? Cool with this.
Very.
Now, is G the same for both of them?
Yes.
Yes.
Hopefully.
We're both on
Now, the oil is floating. So what do you know about the density of the oil?
Less than
Less is
water.
water.
It's less dense. So the density of the oil is a little bit
I
smaller,
didn't think
right?
that either.
Are you
Yeah.
Times the same G. So to make up for it,
Floats.
the height has to
How
be.
did you not know?
I would associate thickness with density.
No. Don't confuse viscosity with
I
density.
feel like I've been
Why?
lied to.
Wait, what's
Why?
more dense?
I feel
milk?
like I've done this lab so many times in a lot of other science classes, and it's never been that oil is less dense than water.
Promise you.
Why is it?
You probably
Okay,
didn't
if
use
there is
oil.
a science teacher in the world that has told you that oil is more dense, I want their names.
Mr. Law.
Okay?
Taking the cold.
I don't know.
What about milk?
I
Our
feel like
camp takes no proof.
That's about the same because oil is mostly water. Milk is mostly water. Has some actually
You're
fat,
mostly
fats in it.
water.
Might be a little bit less dense.
No way.
Okay, so here's what I want you to see.
That's crazy.
Is that at this depth right here, the pressures are the exact same, okay? So the reason that the oil is a little bit taller is that to generate this part of the equation, since it's less dense, it has to compensate by having
More height.
more height,
Yes.
Oh, okay, that makes sense.
okay? That way I have the exact same pressure right here. And it doesn't make any difference which point I pick. If I pick a point here, okay,
It's the same.
pressure's gonna be the same, okay? Doesn't make any difference, all right? Makes sense. Got this idea?
Yes.
Okay. Now, what if I blow on one
I thought you were
side?
gonna drink it.
If I blow on one side, and I'm not going to because I don't have real, well,
You need to pour some out.
Polo G.
okay? Because if I increase the pressure on this side, what's gonna
I'm
happen?
so proud of you.
Should go,
It should shoot up on the other side.
Yep. More pressure.
It's like a
Okay.
tuba.
kind of.
Trombone, that's the word.
Trombone. So when I increase the pressure here, what happens?
Pressure.
Height.
If there's more pressure here, this side's going to go
Higher.
higher. So what they used to do,
I'm good.
That's gonna spill.
Okay.
Or is that
I'll hold it. I'll hold it.
no, 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 no.
Get your hands off. Did it even spill?
No,
That's impressive.
You said no.
Count like reflexes.
this is the oil.
You have 8 lives now, Mr.
So
health book?
now, what if I did this? What if I had this pretty far apart?
Yeah.
Hold on.
Those gummy bears are trash.
Yeah, they
You're
suck.
just gonna take that?
Those nerds things
Me
suck.
personally, Louis?
I don't care.
The nerds?
Those are awful.
The nerds are so
Those
good.
are awful. I don't
Okay.
like super sweet stuff.
So what if I did this?
Huh.
What if instead of being symmetrical, I put like a big, where it flares out like this?
Still be equal.
Okay?
Oh, boom, boom, boom.
And here is, I got water on this side, okay? And I've got oil on that side.
Like oil's
Okay.
above that line.
So there's water here, and then I have oil above
Okay.
there. So I've got this big funnel over here that I'm gonna fill with oil,
Yeah.
okay? So this is the depth of my water. So here's my question, I've got this big funnel over here.
Yep.
So I'm gonna fill this side with oil. Big funnel, big surface area,
Big funnel.
big funnel.
Big.
So is this height of this oil gonna be less than the height of the water? Still above the height of the water, or just exactly the same?
Above.
Above.
It has to be above.
It's above.
Why does it have to be above?
Surface area doesn't have to do with.
Don't plug volume into
doesn't-
that
Volume
equation.
doesn't have to.
Because
do
rho
with
Yes.
is less, has to be.
This has, the fact that that's a funnel,
Doesn't matter.
doesn't matter. Okay? Look at what is a factor in the equation. Okay? Doesn't make any difference. Now, this is where it gets a little bit interesting.
Oh no.
What if I do have this? What if I have this?
What?
But I put a little toy boat in it.
It depends.
It's gonna go higher.
Wait, are we considering where the level will be with the boat in it?
Yes.
It's gonna go higher again. Because the boat displaced more water, so it goes higher. It's like when you get in a bathtub, it raises.
Yeah.
It's the
No, no,
place
no,
in
no, no,
oil.
no.
Yeah.
No, it has. It's
If
still
it's
the
not,
same-
if
Oil,
it's
but
Yeah,
not.
it's still gonna be
Still
higher, but it's
higher.
gonna be the same amount higher.
Oh, I see, but it's
Push water out.
because there's
What
more
did you
because
just say?
force gravity acting on the oil is pressing down, so the water has to come up a little bit more. Yeah, the water has to
The
come up
water
a little
will
bit
go
more.
up.
So it's gonna be
It'll
equal.
be the same.
Vitor, what'd you say?
The water will go up.
Why?
Well, because
There's more pressure.
the bow pushing down, like
Water
it's
has
gonna,
to equal
it's
out.
the water has to go upwards to equal out the pressure.
Because that would be just like me blowing on one side of the tube,
Yeah.
okay?
No.
Yes.
Yeah.
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 Is it?
Yeah.
What do you mean no?
He's still questioning.
You're wrong.
Well, sometimes
Questions
he'll
or
like
no?
be like, okay, and then he'll just pull out the Uno reverse card on you and just
Yeah, and that,
Wrong.
don't get me wrong, that has been what happened.
yeah.
Okay, in this case, that isn't
Alright.
bad, okay? So if I put a boat over here,
Psych.
right?
I love
Now, it used to be, in the old days, before they had good pressure gauges, what they would do to measure pressure, like in chemical reactions, is they would have like a reaction take place, and then they would have, I screwed that up.
6.2 doesn't exist.
Imagine.
Just graduate from
Okay.
NPC class.
And they would have this actually open. So imagine that you have like this big U-shaped open tube
Like a toilet.
that's open to a container inside that where the chemical reaction is taking place.
Oh.
So if your inside pressure is the same as your outside pressure, and you would have like mercury, water, oil, something like that in this tube. So if the reaction took place and it increased the pressure inside the vessel, what would happen over there on the tube?
Height would have
Goes
to
up on the other side.
Yeah.
go up.
So you'd have more pressure pushing here, and this side would go up. Okay? If it consumed gas and it decreased the pressure, then
Opposite.
the opposite would happen. Okay? So that used to be how they would determine gas pressures before they had good pressure sensors. Is they would have like this open tube, and that's how they would measure it.
Oh.
Now, if you've ever studied barometric pressure, one of the things they'll talk about is barometric pressure in millimeters of mercury.
Is that
Okay?
fair?
So, millimeters of mercury, 760 millimeters of mercury is about like yay. Because how they used to measure atmospheric pressure, it was almost like a thermometer,
Thermometer?
and they would have a pan of liquid mercury, which we can't have anymore, spoiled all of the fun. And they would have that mercury
Facts were old
in this
times.
pan, they would have it open to the atmosphere.
So what's gonna happen?
And what they did is they kind of made a mark, and they said, hey, this is a nice round number. We're going to call 760 millimeters of mercury standard atmospheric pressure. They could have picked 759.6. They could have put 765. They said 760 sounds like a good number. Okay?
Why didn't they just use one?
We'll get to that.
Oh, okay.
Okay? But literally, if you
Mercury's
measured
not
the
that.
height of that mercury, that would be the height of the mercury in the tube. Okay?
Oh.
Now, if you had a low pressure system move in, usually associated with rain, because if you look at what's creating that height, you have air pushing down on that surface, and it's pushing that column of mercury up, that mercury up into that column. Okay? So if you have less pressure, like a low pressure system moving in, then there's less pressure in here and on the outside, so that mercury would fall. So if you ever listen to the weather, if you're a weather junkie, they'll say, oh, atmospheric pressure is falling. Okay, it's falling because of the fact that typically moist air is less dense, and therefore that there's less pressure pushing on that mercury, and you would see that fall. Now, if you have a high pressure system where air is sinking, okay, because of the fact that it tends to be more dense, then as you increase the pressure on that mercury, it would push that column of mercury up into the tube, and this is why we call it high pressure, because it would push that system up. So to say, if you listen to the weather, say, hey, atmospheric pressure is falling, rising, and that was an indicator of weather, because they knew typically rainstorms, whatever, hurricanes especially, are like the mother loads of low pressure systems. Especially in the eye of the storm, it's an extremely low pressure. So what you would see with that extremely low pressure is that you would see that mercury drop like a rock because of the fact that it had less air pushing down on top of it. Okay,
So like,
Wait,
what
so
would it
it-
feel like to be in like a really, really low pressure system like that? Would
It's,
anything
it's
really
it would be
change?
almost
or-
like going up into the
Florida.
mountains.
Oh, okay.
Yeah,
So it's
What about
yeah.
a
But
tor-
it'd just be happening
what about a
rapidly.
tornado?
Pop.
How'd they determine
never
what
been in a-
standard is?
never been in the
So you're
world
saying it
tornado?
varies from that
I'm saying what the
760?
pressure.
No, what they decided is that they defined 760. If they got together, played rock, paper, scissors, and said, okay, let's settle this. So they said 760 millimeters of mercury is what they were going to define as a standard atmospheric pressure, which then became 1 atmosphere. Okay, which then became 101,300 newtons per square meter, which became 101,000 pascals, which became 101.3 kilopascals, which became 14.7 psi, which became 760 torr.
So what is torr?
Huh?
What is torr?
Torr is just the same thing as millimeters of
The
mercury.
site you
Wait,
used to get on the
so they
dark
just
side.
had the certain amount of mercury, and whenever it was, they had that at 760, that's what they had as normal?
That's what they said. We're going to make a mark, and we're going to call that standard atmospheric pressure.
Oh, so does it, so whenever it's like low pressure, high pressure, it varies from that then?
Yes.
By like how much?
A lot.
Typically, like a high pressure system, you might go up to like 776. Low pressure systems, you might go down to like 754. Okay, so there's not a huge
Not
variation
surging.
on that. Okay, got that idea. Now you've been sitting, stand up, take a stretch.
Thank you.
What did Clemson have to
Damn, we only got 20 minutes. Good news, bad news.
Kind of.
What do you mean, kind of?
Bad news, bad news.
I'll be here on Friday, Mr. Bird.
Lecture all day. Lecture whole class and homework.
Centimeters, so 0.15 instead of 0.015. So when you end up
We're doing-
We're just
for our
finishing this
final?
up and starting the review for the final on Monday.
I'll be here on Friday.
Okay.
Would I be able to come in during encore tomorrow?
Because I think we like, I was leaving and I'm like, something's wrong with this.
Yeah, I
I'm gonna
just
figure it out later.
If you are not here in encore, I'm grading what you have done.
Okay.
You understand this?
Yes, I'll be here.
Okay, you understand this?
Yes.
Okay, with my class is my witness,
Okay.
okay?
Don't show up. You'll be fine. I promise.
It's a good thing we don't play soccer in a class.
France,
Because I got shoes on.
Morocco.
France is up.
Why you shooting? Why you shooting?
Oh
Don't tell
man.
him. He's gonna have a reach.
Hey Vitor, the World Cup score is
What's the score? What's the score?
No, stop.
So when's the final?
Oh my God.
No.
it's gonna be
It's either Morocco
I think it's
or...
the
No,
17th.
when?
17th or 18th.
Isn't it this
18th final, third place,
Sunday. Hey,
17th.
don't talk about the
Oh, they'll play for third?
Yeah.
The two losers
That's
of
like-
the semifinals or whatever.
Hey, did you
Or
check
whatever.
It's like, does anyone
Yeah.
really care about that one?
No.
I'm not saying
Depends who's in
anything.
it. If Argentina's in it,
I
they'll
gotta
care, but if
respect
not, then
Vitor
nobody really
today.
cares.
Okay, all right, here we go. Hip, hip.
Hooray! Hooray! You were recording that whole time,
That's
bro.
so weird how like a
Hooray!
concentrated
That
yellow
needs to be a
food dye
part of
is
the
like
You get
red.
people.
It's like
still
red
on?
like that.
Yeah. Beckham gets to have a break too.
Okay, you just keep it going?
Just
Yeah.
making sure.
David.
Okay,
David.
all right, so here's what I'm gonna do. So I've got yonder syringe,
Yonder.
and I'm going to draw some of this fluid up into the syringe. Now, here's the question. Is the fluid sucked up into the syringe, or is the fluid pushed up into the syringe? So when I do this, okay, get rid of the air pocket,
Sucked.
No, that's pushed.
okay?
Hold on,
So,
Sucked.
was the fluid
That's a
sucked
bottom.
up into it,
let me think.
or was it pushed
When
up into it? Vitor.
when you increase volume, it decreases pressure, and so that
There's an imbalance in pressure.
it's an imbalance in pressure in the
Yeah.
syringe.
Yeah.
Which-
So here's the question: did I suck it up into it,
Push.
or was it pushed up into
You're
it?
pushed.
That's the central question.
Pushing it with what?
You're pushed because it's like wind, right? So if there's a low pressure system, which is the syringe, right? Then the high pressure system, which is the cup and all of the air pushing down on the outside, it's pushed into the syringe.
Yeah.
which
You
is
mean
a low pressure
boost?
system.
So yeah, you got the low pressure in there, and so the pressure, the higher pressure out here pushes the water down into there.
Because
Like,
P equals
those
rho
valves
GH.
Suck the water.
Yeah,
No,
P
it
equals
pushes
rho
the
V
water.
wave.
Yes.
That one.
Yeah.
Because science never sucks.
I like that
No.
joke. That joke is funny.
Now,
Oh.
what you can do is you can create negative pressure, and then Mother Nature tries to equalize this. And here's an interesting thought. What if I tried to do that and I was in a vacuum?
You couldn't,
It wouldn't do anything.
because you couldn't suck that up. It wouldn't matter.
Why?
Because it wouldn't create a difference of pressure if there's
Yeah,
no
there'd be
pressure to
nothing
begin
on
with.
the outside
Yeah. There'd be no
to
pressure.
push it up into it.
Or,
Yeah.
We should
you
try
know,
it.
atmospheric
Now,
pressure.
You said it sucks, bro.
when you breathe,
I didn't
it's
say
the same
anything
idea.
I
sucks.
said it sucked.
when you
I was just saying
breathe,
there's a
you
pressure.
suck air in, or you just create negative pressure where the air is pushed in.
Negative
Negative
pressure.
pressure and it's
You create negative pressure, okay? Because what happens is that your diaphragm in your stomach goes down. That creates negative pressure. It tries to equalize it out, and that air gets pushed in. Now, so let's talk about this equation right here. Area 1, V1 equals area 2, V2. That is not volume, okay? That is velocity.
What?
So this is,
No way.
I'm just telling
Calm
you,
You
down.
should do like a little V or
I
something.
can't stand it.
okay? So this is the cross-sectional area of the syringe, okay? So look at this. So I've got this cross-sectional area here, this syringe. And that V1 is going to be how fast
Into.
I'm going to push that plunger. Area 2 is going to be the cross-sectional area of the end of the syringe. And then you're going to have V2, which is going to be the velocity of the fluid as it goes out.
Yeah.
Okay?
Is that meters squared? What is that?
Yes, it's
Area.
meters squared
Yeah.
times meters per
I
second.
know, but it kind of looks like an N.
So when you do
Moles
this,
squared.
when you take meters squared times meters per second, what do you get?
Meters per second.
Meters cubed per
Oh,
second.
meters cubed per second.
What do you think meters cubed is? to measure of?
Volume.
Oh, so this is like volume
Per second.
per second. Now, there's an equal sign here, which means that these two sides
Equal each other.
have to be the same. Cool with this, okay? This is what's known as your flow rate, okay? It's cubic meters per second. If you're ever a petroleum engineer, you live and die by flow rates because
Okay.
how much product is moving through the pipeline, how long it's gonna take you to fill a tank, okay?
This is where the big money's at, right?
This is where the big money's at,
Ooh.
okay?
Big
And the
money.
big explosions, but let's not talk about that.
Let's go.
So
Wait,
here's
wait,
my
like-
Sounds like a
question.
Like
job
by
for me.
accident or like on
Oh,
purpose?
yeah, no, by accident.
Oh.
So here's the story. So we're gonna look at this syringe, which sounds odd, but trust me. So when I look at this syringe, and if you're ever in a significant relationship with someone and they use that line a lot, that's kind of a red flag. I can do it with it because I'm a physics teacher.
What's the one?
So,
Just take one
Huh?
bag.
What's the one?
here, look at my syringe. That's like, unless they're
Oh.
like a
You didn't
diabetic.
even take
So,
Diabetic?
here's the visual, okay? So here's the syringe, here's the plunger, right? So this side over here has a big area, right?
Yeah.
This end here has a
Small area.
Small area.
very small area, okay? So then to equalize these out, what has to happen?
Velocity has to get bigger.
Velocity over here is going to be small. Velocity over here is going to be,
Is that
Big.
how rocket engines work?
yes. It's also, if you've ever like washed your
Piston?
car and you had a garden hose, what do?
Put your thumb over it.
Put your thumb over it. This is
Put
what.
your mouth on.
This is the
Whoa.
mathematical reason.
Oh, that is dumb.
You definitely did that, Luke.
What you trying to
Take
say?
a golf ball through a garden hose.
Louis would be the kid to.
He sucks a golf ball
No.
through a garden hose.
Becoming a smaller area, so
Yes, only faster.
Yeah, you
Here.
plug it in and then it just comes out
Nozzle,
your nose.
no. Okay?
No, nothing like that.
All right.
Thirsty.
I'm just thirsty. So here's the story. So here's the whole basis of this. The whole assumption of this is that, imagine that you have like a slug of water, okay? Slug of this fluid. And you have, and because it's cubic meters per second, it's a flow rate per unit of time. So you've got you got the slug of water that's moving through. So what happens is that to make these things equal, you've got to, because the flow rate here, cubic meters per second, has to equal the flow rate here going out. So what that means is that this is going to move slow, but to balance it out, that end has to go fast. So you can show that, right?
Let's do it.
So if I do this,
Whoa!
okay.
Look at that one.
His peens.
Sit down.
Too many
I don't
papers.
want you whining.
Too many papers.
Okay, you ready?
I'm whining.
Oh!
Okay.
All over the paper.
Okay.
That was not nice.
I should have won.
Yeah, that
Okay.
took me a little bit.
Wow.
It's all gone.
Hey,
It's all
over our-
I can't see you whining about the lab. The lab's so.
Okay, good.
That's your.
I got alcohol on
Yeah.
pop slab.
Oh,
Okay.
Oh, okay. I was
So-
like, where did you get out?
This is why
This off
when you take a syringe or a garden hose or whatever and you put your thumb over it, this is why the water goes faster.
Yeah,
This is
look
the
at
whole idea of
What are
nozzles,
those gummy bears doing to you, bro?
is that you're decreasing your surface area, okay? So to make up for the smaller area, the water has to go faster. Now, Pop, or Vitor, give that a spin over here.
Did it.
Spin that song. 360. No scope.
I was trying to crush it.
How'd that work?
It floated.
Dude.
So, Pop.
Hey, a second try.
See this.
2 times.
Louis, Pop, yes,
Get out the way. Move. Pop. Get out the way.
So what I'm gonna do is I'm gonna turn on the water, and what I want you to watch is the cross-sectional area of the stream, okay? So what do you notice about the stream as it falls?
It's wiggling.
It becomes more narrow.
Yeah.
Why? It falls faster.
So the volume has to decrease.
No, 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 no,
Area.
no, 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 no.
Area.
Oh, area.
How does laminar flow work
Area
thing?
has to decrease.
How does
Because it's the same amount of water, so that's why as it falls, it narrows.
Yeah.
Because the velocity is getting faster, so to create that same volume per unit of time, it narrows down. Okay?
You need to get that water checked, by the way.
How does-
It looks like microchemicals.
That's why I have the jug of water and not that.
I drank that water though.
It's not,
you?
it's not as bad as it used to be.
So how does laminar flow work?
That's scary.
Oh, then you get into Newtonian and non-Newtonian fluids, and that gets bad. Okay.
It used to be.
All right, there's only like 3 minutes left. I don't have to, well, tomorrow, no, you have no homework. Okay?
Get in.
So,
Get in.
so here's the drill for tomorrow. Actually, you won't have any homework for the rest of the time. So, tomorrow we'll finish up what's known as the continuity equation, and then we're just gonna start the review for the final, which is gonna be on Monday. Okay, and we're gonna go way back into a whole bunch of different things, because it's like from the first day you were in here.
Continuity?
We got a hammer, huh?
V equals V naught. V equals V naught plus AT.
What?
You say continuity?
B squared equals B naught squared plus 2AD.
Bernoulli's
That equation. What is that equation? V squared plus.
No,
B squared equals V naught squared plus
Anyway, so that's the story.
That's that
V equals in
We'll
this.
call it a day. It was a good lecture. So,
D equals X, Y, Z.
It's just like, I didn't understand how to.
You guys are tripping right now.